In this lecture, we're going to learn about functors with parameters. And these are functors we can set up and give them member variables that can store state of a given functor object. Let's look at a simple example here. We're going to set up a simple functor, which is going to be called in range. And we are going to attach a concept to this, which is going to force us to use this class only with arithmetic types. So this is what we want to set up here. But because this is a functor, it will need to have a function call operator. It is what we have here. It is going to return bool and it is going to take a value. And what this is going to really do is to check and see if the value we pass as a parameter to this operator is within a given range. And the range is going to be controlled by the member variables we have here. So the range is going to start from the minimum and end from the maximum. And all these things are going to be inclusive. This is what we set up here. Notice that because of these member variables, our functor here really has state. When we create an object of this functor, we're going to pass the data for these member variables. You can see that we have a constructor here, which is going to take the minimum and the maximum. And this data is going to be forwarded to these member variables through the initializer list that we have here. So our functor here can really store state, and it is much more different from a regular function pointer because of this state that we have here. So if we have this, we can, for example, use this in a function as a callback. So we can set up another function here, which is going to compute the sum of elements that are within a given range. And we are going to attach a concept to this, which is going to force us to only use numbers with this function here. If we try to use anything that is not a number, this concept here is going to fail and we will get a compiler error. So what we do here, we pass a second parameter, which is going to be a callback. You see that we have set up a second template parameter, which is really going to model our functor. And we really have the flexibility, again, to pass any kind of callback. We can pass a functor, we can pass a function pointer. Any of those is going to work. When we hit the body of this function, we are going to set up a variable which is going to store our sum. Then we're going to loop around, summing up things we want to do the summation for. Because this thing is going to sum up things that are within a given range, we will use our callback here to see if the current element we have at the current iteration is within a given range. If it is within the range, we're going to add that to our sum. And by the time this loop here is done, we will have our sum stored in this variable and we will return this to be used by whoever might have called this function here. So this is how we can use the state that we have in our functor to control things. In this case, we are using the member variables that are in our functor to control the minimum and the maximum of our range. Once we have this set up, we can do something like this. For example, we can set up a box container of doubles and we can control and make sure that we sum up things that are within a given range. And we can do that like we see here. We can say range sum and pass our box container. And then we're going to pass our functor, which is going to test and see if the current iteration in our data is in this range here. So this is the minimum, this is the maximum, and anything that is within this range is going to be added up and we will return the sum and print this out. We can also use another range as we see here, and we're going to see what we print out when we hit Visual Studio Code in a minute. Down here, I want you to see that if we try to use a box container containing the types that we don't support, we will get a compiler error. Here we are trying to put in a box container of std strings. So if we try to use this, we will get a compiler error saying that our arithmetic concept is not satisfied. And this is how we can make our code much safer to work with. Here we have another example of a box container that contains integers, and we can really do the same things here. We can sum up things that are within this range, 10 and 20, and we're going to get that sum printed out. We can sum up things that are within 10 and 30, and you're going to see that these things are going to work here. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is Functors with parameters. We will reuse the code from the last lecture, so let's grab everything from there. And we're going to put that in our current project. We can open this up in Visual Studio Code by dragging and dropping here. And we can open up our main CPP file. We are going to clean it up a little bit, so let's remove everything because we're going to start from scratch here. And we can remove everything we have on top. We don't need all this now. We are going to remove the functional header and include the concepts header because that's what we need for this lecture. And we're going to set up our functor that happens to take a few parameters. So we're going to have a bunch of member variables in. The first one is going to be controlling the minimum of our range, and the other one is going to be controlling the maximum of our range. And all these things are going to be inclusive, so the minimum and maximum are going to be included in our range here. We will pass the data for our range in a bunch of parameters that we pass to the constructor. And this data is going to be forwarded to our member variables here. And this functor can store state. This is a functor because we have the function call operator overloaded here. And we are going to use this operator to test and see if the number that we pass as a parameter here is within this range. If it is within the range, we're going to return true. If it isn't, we're going to return false. This is the setup we have here. Now, we can use this functor to do things. What we are going to do is a function which is going to sum up things that are within a given range. And we will set it up as you see here. This is going to be a templated function. It is going to take the first parameter as the type that we store in our box container. The second template parameter is going to store our callback function. And this callback function can really be either a function pointer or a functor. Either is going to work just fine. We're going to hit the body of the function and set up a variable which is going to store our sum. Then we're going to loop around, checking if the current iteration is within our range. And we do that by using our callback. As we see here, we're going to test if the current item is within the range. If it is, we're going to add that to our sum. If it isn't, we're going to ignore it. And by the time this loop here is done, we will have our sum stored in the sum variable, and we will return this to be used by whoever might have called this function here. So now that we have these things in, we can hop over in the main function and use them. So for example, we can set up a box container of doubles and we can add data in. And we can say we want to sum up things that are within this range. So 10.0 and 15.5, that's going to only be the 10 here. So here we should print out our 10.1 because that's the only thing that is within this range. And if we change the range to be 10.0 and 21.5, the sum is going to be 30.3 because we're going to sum up 10 and 20. Hopefully you can see this. And we can try to build and run this program to prove that these things are really working the way we want. Notice that we are building our functor in place and giving it the range that we want to do the summation for. This is how we can do these things. And our function call operator is going to return the result directly. You can see that it is going to return a T as you see here. So that's why we are able to print it out directly in our stdc out statement. We can pass this through our favorite compiler, which is GCC. The build is good as you see down here. So we can bring up a terminal window and we're going to clear and run Rooster. And we're going to see that the first sum is 10.1 as we expect here. And the second sum is 30.3 as we expect. So our range is really working. If we try and change the second range, for example, to also include the 30.3, so we can say 41.5 as the closing range. And if we build again, we're going to see that the 30 is going to be included in our range and the sum here is going to change a little bit. So we can clear and run Rooster, and we will see that the sum now is 60.6. If we try to add something that is within the range, we're going to see that. Let's do doubles, and we're going to add and maybe put in a 15. Why not? We're going to see that we're going to add 15 to this sum here, and everything is really going to fall in place. Let's do that. We're going to run the task to build with our favorite compiler. The build is going to be good as you see here. We can clear and run rooster, and we see that our sum now has changed and everything is really working as we want. Now, because of the concepts that we have here, we're going to see that if we try to use either the functor or the function with something that is not a number, we're going to get a bunch of compiler errors, and I want you to see that. We can go down here and set up a simple separator. We're going to say stdc out, and we're going to try and create a box container of std string, and we can say strings add, and we can say hello, and we can also put in world, why not? So let's add world here. You're going to see that at this point, if we try to compile the program, we're going to see that it can work. So the build is going to be good. But if we try to compute the sum and do something with that, we're going to see that our program is going to blow up. So let's do that. We're going to say range sum, and we're going to say strings, and we're going to pass in a functor, which is going to be is in range. We're going to say that this is going to work on std string as our type, and then we're going to say hello and say world, why not? Okay, so if we do something like this, the first thing is that what are we going to get by summing up strings like this? So this probably doesn't make sense, but our concepts are going to protect us because we can't use our functor here with something that is not a number. That's why we have this concept here. We also can't use range sum with types that are not numbers. If we do that, the concept here is going to fail and we will get a good compiler error. That's why we did that, to make our code a little safer to work with. So we can go here and run this through our compiler and get a bunch of compiler errors. And we are going to see that we have some concept failures. For example, we see template constraint failure for this little guy. So the concept here is not satisfied. If we go down, we're going to see that we have another concept that evaluated to false. So the concept has failed and we know where the problem is, so we can fix that. And the problem is that we can't really use this functor with something that is not a number like std string. We also can't use the range sum function with something that is not a number. And that's the problem we have. So we shouldn't really be able to do this. And our code is much safer to work with. But things are going to work just fine if we use something that is a number. So let's go down and set up a box container of integers. We're going to do that like this. It is going to be called ints, and that's going to contain a bunch of integers. We can put the data in, and we can see that if we do a range sum, this is going to work. We can sum up integers, and those integers are going to be within this range. So if we grab things that are between 10 and 20, we're going to grab this 10 here, and I think that's going to be the only thing. So this is going to give us a 10. And if we sum up things that are between 10 and 30, we're going to grab the 10 here, we're going to grab the 23, and this is going to give us 33. And if we build and run our program, that's probably what we are going to see. Let's make sure that's the case. The build is good. So we can clear and run rooster, and we're going to see 10 and 33, exactly what we expect in our C++ program here. This is really all I had to share in this lecture, showing you that we can set up functors that have member variables, and this is going to allow our functors to store state. And in this case, the state is the range that we can do the summation on. And if we want, we can even set up setters that could change this state. You're going to be able to modify these things to suit whatever you are targeting in your design with C++. In the next lecture, we're going to see that what we just learned about here is the basis on which Lambda functions are built, and that's going to be really cool to understand. Go ahead and finish up here and meet me there.